Hi everyone, my name is Mu Jingyi from Nanjing University of Science and Technology. I'm glad to introduce you about our work, learning clothes in relevant cues for clothes-changing person re-identification. First, I will briefly introduce the person re-ID task, given a query for searching, and then match this person in a gallery consisting of cross-camera images or video sequences. Due to these images are taken by different cameras, it will face some challenges, such as viewpoint, illumination variance, cluttered background, occlusion, changing poses, and so on. Our work is person re-identification in clothes-changing scenes. What is clothes-changing person re-identification? In the training and testing set, the same person has different clothes, so the clothing information that is originally very important for identifying will become unreliable. So, we have used some methods to solve some problems of clothes changing. First, we propose a clothes relevant information erasure module to erase the clothes relevant information on the original images. We utilize a pre-trained human parsing model to obtain the semantic information of the human body and identify the clothing parts of the human in the original image, including upper clothes, pants, dress, skirt, belt, bag, and scarf. Then we erase these parts and retain the other close irrelevant parts. We put the generated images into the network for training, so that the model can learn more biological features which are close irrelevant. What's more, we can also obtain the banded body shape masks for use by the next module. After sending the original image and the erased image into the network, we hope the network can learn some closely relevant features adaptively, but at the same time, the model may focus on some interference information in the background. To enable the model to focus more on the human body, we introduce a body shape guided attention module in the network, using the previously generated banded mask to do a convolution, and then concatenate it with the feature map after a dimension reduction to get an attention map. But the original feature map also makes a certain contribution in this process, so we multiply it with the banded mask once again, and then get a final attention map. This module is embedded between the ResNet 50 stage 2 and the stage 3, so this is the framework of our model. In our approach, since each person has more than one kind of clothes, to fully extract the clothes' irrelevant features, we mind triplets through the following method named batch cross-clothes manning. In a mini batch, Xi is an anchor, Xj is a positive sample with the same identity but different clothes label, and Xk is the negative sample closest to Xi. In this way, we can sufficiently minimize the distance between the positive pair of different clothes without introducing a large number of simple triplets. There may be more than one positive sample which has different clothes labeled from the anchor. Our method actually performs quite well. These are the results of the comparative experiments on 3 datasets. SC is same clothes setting, CC is clothes changing setting. We can see that our method outperforms all other methods in clothes changing setting. However, the performance of our method in same clothes setting is not the best. The main reason is that our method pays more attention to clothes irrelevant features, such as head and leaves. Although these features have certain discriminative power, close relevant cues contribute more to identification when clothes remain unchanged. Therefore, the performance of our method is reduced but still at a high level. In NKUP dataset, each person wears 2 or 3 types of clothing. The top one accuracy of our CRE outperforms all other methods. For further analysis, we visualize the learned attention maps in the BSGA module in right figure. We can see from the rough outline of attention maps that these attention maps highlight the human body parts and suppress background clutters. To visually observe the final performance of our approach, we use class activation mapping to visualize the heat maps of the input images. And the results are shown in left figure. from which we can see which part of an image contributes more to the final output of the model. We can observe that, first, the baseline method pays more attention to close relevant features, such as color, texture, style, and so on. Second, our method pays more attention to the close irrelevant parts, such as the face, feet, legs, arms, and key points of contour which are important discriminative features. Besides, our model is rarely affected by background noise. These heat maps make it more intuitive that our method learns richer close irrelevant features, which are beneficial for the close changing reality task. Finally, I will make a conclusion of our work. First, we erase the close relevant information from the original images so that the model can adaptively explore close irrelevant cues. Second, we further utilize the body shape mask to get the learning of the attention map, which makes the model focus on richer and more discriminative features. Third, thorough experiments on free close changing reality benchmarks demonstrate the performance advantages of our method. Thank you for listening.